Before we leave alpha behind, I just want to mention that alpha's kind of a big deal. He's going to become very important to you in chapter 10, chapter 11, chapter 12. He's called the level of significance in those chapters. So for this chapter, he's the level, he's the complement, if you will, of the level of confidence. And just keep in mind that bigger things are happening for him. Now, what would happen if we kept the data from our original scoop, but we wanted to raise the level of confidence? Instead of being 95% sure, suppose you want to be 99% sure. How could you do it? What could you do? So, first of all, let's start with this. How could you do it? Think about it for a second. If you want to be more confident, but can't change, oops, you can't change the size of the sample, then simply make a larger interval, right? So let me give you an analogy here. If you want to be more sure that you're catching the magic fish, i.e. P, population proportion, P, then fish with a bigger net, right? Use a bigger interval. Make it 99% instead of 95%. You'll be more certain. All right, how will that look for the interval? And I drew kind of a picture here, but let me go back and draw it on this just for a second. Hold on. Okay, here we go. So let's suppose that, and I took the error away, but it's the same picture as before. So let's suppose that the orange one from before is the 95% confidence interval we made already. So 95% confidence, CI, confidence interval. Oops, I apparently didn't press the right button. 95. Percent CI, or C, yes, CI. And then let me say that this one up here, the red one that I drew, kind of above the line, but you get the gist, would be the 99% confidence interval, for example. Okay, it's larger. You're more certain you caught what P really was. See, you're 95% certain in the original place that you've got P somewhere in here to here. I mean, you don't know for sure. It's not like you took out every bead in the box, but you're 95% sure you caught it. So when you make a bigger interval, then you're more certain you caught it, right? So you make a lower this ending over here and up, or raise this ending up here, and you've got it. And that's sort of what I was trying to draw here, right? The higher level of confidence gives you a bigger interval. But there's a problem with that. Well, there's several problems, but one of the big problems is that you can make an interval so large as to be useless. I mean, for example, suppose I said that the percentage, oopsie, if I can spell the word percentage of red beads in the box is somewhere between 10% and 80% with 99.999% confidence. You've got huge amounts of confidence, but it's totally useless. It's like saying, okay, I'm sure that the president's approval rating is somewhere between 0 and 100. Well, yeah, no duh. Of course it's between 0 and 100. I mean, this box is somewhere between 10 and 80% red. Really. You know, took you all day to figure that out, right? So you can make the interval so large as it's pointless. It doesn't give you anything and isn't useful. It's called accuracy, right? You're losing accuracy in your guessing. You're not able to give a nice, accurate guess of what's happening. Okay? So how could we get a better interval without doing that, without creating such a nightmare? And the answer is use a bigger scoop, i.e. sample size. And that's where we'll pick up next time.